Today, we are diving into a problem that, let's be honest, drives almost every software project a little crazy. How do you take complex, real-world rules and turn them into clean, working code? We're going to uncover a really powerful, but often kind of overlooked technique called domain-specific languages, or DSLs. And trust me, they offer a much, much smarter way to build software. So let's kick things off with a pain point that anyone who's ever touched software will immediately recognize. You've got business rules, right? And to the experts, they seem totally clear. But the second you try to translate them into code, it just becomes this tangled mess. Why? Why does this always happen?
Let's make this really concrete. Imagine you're building an app for a car rental company. You've got rules for daily rates, weekend discounts, different contract types, mileage caps. The list goes on and on. A developer trying to code all that is almost guaranteed to create this just horrible web of nested if-else statements. It's confusing to write, it's an absolute nightmare to update, and for the business expert, the person who actually knows the rules, it's nearly impossible to look at that code and say, yep, that's correct.
But what if there was a better way? This is exactly where DSLs come into the picture. They've actually been around for a while, but like this quote says, they've often felt like this well-kept secret, maybe because we haven't done a great job of explaining them simply. Well, our goal today is to fix that and show you just how elegant this solution can be. Okay, so what exactly is this secret weapon? Let's break down what a domain-specific language actually is. At its heart, a DSL is a small, specialized language built for one job and one job only. It's not like a general-purpose language like Python or JavaScript that can do pretty much anything. Nope. A DSL is hyper-focused on a single problem area, what we call a domain. That could be insurance claims, financial trading, or, in our example, car rentals. And this, right here, is the key benefit. It's brilliant. A DSL speaks the language of the expert, not the programmer. So instead of dealing with things like loops and variables, a car rental manager gets to work directly with concepts they already know inside and out: business rules, conditions for a discount, attributes of a rental. It just completely closes that gap between the business logic and the software itself. Now, you might be thinking this all sounds a bit like magic. I mean, how can a computer possibly understand these simple, human-friendly rules? Well, the secret isn't magic. It's a really clever data structure that acts as a blueprint for all that logic. Just take a look at this rule. It reads almost like a sentence you'd just say out loud. If the rental period contains a Saturday, then add 10% to discount. It's totally clear. A business manager could write this, a developer could read it, and they both understand the exact same thing. That clarity, that's the first piece of the puzzle. But here's the really clever part. While it looks like plain English to us, the system doesn't see it as just a random string of text. Nope. Under the hood, it's being parsed into a perfectly organized, machine-readable format. And that format is called an abstract syntax tree, or AST for short. Now, don't let the name intimidate you. Seriously. Just think of it as the ultimate blueprint for your business rules. Every single part of that sentence, the if condition, the then action, the values, it all gets broken down and stored in this logical tree-like structure. So this isn't just text anymore. It's pure, structured logic that a computer can perfectly understand and work with. Okay, so we've got this super powerful blueprint, the AST. But, a business expert isn't going to sit there and edit a raw data tree. So how do we make this whole thing accessible and, usable? The solution is this really cool concept called projection. We take that raw AST data, that blueprint, and we project it into a visual, interactive editor. We're essentially building a custom user interface made specifically for editing these business rules. And this shows the magic of that projection perfectly. On the left, you've got the raw structured data that the machine needs. That's the AST. But on the right, that's what the human expert gets to see and interact with. A clean, intuitive editor. Notice how it uses simple forms, drop-downs, clear labels? These are two completely different views of the exact same information, one for the computer and one for the person. And this is what you get. This is the final result of that projection. It's a real editor built using these very principles. You can see how it's structured around concepts like record type, attributes, and business rules. An expert can come in here, define the entire logic of their business, and never once have to look at a single line of traditional code. It's amazing. All right, we're almost there. The expert has defined all the rules in this nice, friendly editor, which has created that structured AST blueprint. But how does this actually become a real running application? This is the final and really crucial step. So here's how the whole thing connects in 4 simple steps. 1. The expert defines the rules in the editor. 2. That action creates our structured AST, the blueprint. 3. A special program called a code generator comes along and reads that blueprint. And then 4. This generator automatically writes all the real-world code, the JavaScript, HTML, and CSS that's needed to build the final application. No manual coding required.
So, why on earth would we go through all this trouble? Well, the payoff is absolutely huge. You get rid of misunderstandings between experts and developers because they're both working from the same blueprint. The logic becomes super easy to read and to change. You cut down on bugs because the expert can only express valid rules inside the DSL. And best of all, when a business rule changes, an expert can just update it themselves and new code gets generated instantly without waiting around for a developer. That's a game changer. When you get right down to it, this is the real magic of a well-designed DSL. It creates a direct pipeline from the expert's brain straight into a working piece of software, cutting out all the complexity and confusion of the old way of doing things. And that leaves us with a pretty fascinating question to think about. What if the future of software isn't so much about writing code, but about describing systems? By empowering experts to define logic in their own language, we're fundamentally changing who gets to create software. What kind of new possibilities open up when the people who truly understand the problem are the ones building the solution?